I am Robbe. I am presenting our paper, Comparison of Cross-Reality Transition Techniques between 3D and 2D Display Spaces in Desktop AR Systems. And with this title we mean that we have a system that's a combination of desktop computing and augmented reality, and we want to investigate object transitions between these two display spaces. We categorize this as a type of cross-reality interaction, which can be one of three types of systems: transitional, substitutional, or multi-user. Multi-user is when there's multiple users in different realities, like systems that allow us to interact with VR user from an outside perspective, like through floor projections or handheld displays. Substitutional is a system in which there is a user that's interacting with an object that typically belongs to a different reality than they are experiencing. This can include augmenting our existing physical smartphones with augmented reality holograms and 3D objects. But this can also include more conventional desktop computing, which we combine with augmented reality, as is the case in this paper, and which can be useful for information visualization. And then finally, transitional systems are systems where the user transitions between realities. For example, when they are being presented with multiple portals in AR and they can choose a portal and step into it to transition themselves from AR to VR, to a virtual reality. But this can also include object transitions, such as a portal which users can reach into to transition virtual objects between VR and AR. In our system we have two display spaces. We have the 2D desktop display space, which is on the physical monitor, and we have the 3D augmented reality display space, which is in 3D space. In our instance we use the Meta Quest 3, which required us to simulate this 2D display space also in the headset, because the actual physical display wasn't visible enough through the video see-through mode to be perfectly usable. In this instance we thus have a physical display with associated input devices like mouse and keyboards, typically associated with the physical reality, and also an augmented reality in which we can see 3D models. And we want to investigate how we can move virtual objects, like our Lego piece here on the screen, and configure them on the 2D display with conventional mouse and keyboard inputs, but then be able to move them out of the display and build with them in 3D space, which is what AR is most useful for. We thus investigated these techniques and we based ourselves on the input modalities. So for the 2D display space we considered mouse manipulation as the native input modality in this area. And then for the 3D space we considered the hand manipulation as the native input method for this area. We didn't opt to use motion controllers, as motion controllers would require users to put down the controllers first before switching to the mouse, and so switching intuitively between hand and mouse was a lot more convenient than having to switch to a motion controller. Based on these two input modalities we created 3 transition techniques and then also a 4th condition to test in a study. The first one is the hand-based technique, where the user can pull out objects out of the screen with their hand, and also likewise they can move the object into the screen with their hand. Then there's the mouse-based technique, which extends the mouse cursor out of the side of the display, where it can grab objects in 3D to drag them onto the screen, and then likewise dragging an object out of the 2D display space into 3D would transition the object into the 3D space. We then created a modality switch technique in which users perform a selection of the object, switch modalities, and then perform another selection, such as pinching or clicking to transition the object. Similarly, when they select the object on the screen with the right mouse click, and then pinch in 3D space, switch modalities to the hand, and pinch in 3D space, the object would transition to that location. And then finally, the last is a condition, which is called modality choice, where users can freely combine hand-based and mouse-based techniques, such as using the mouse for the on-screen transition, but then using the hand-based technique for the off-screen transition. To test these techniques, we devised a task in which participants had to build Lego builds. They could choose bricks from a palette of bricks on the left side of the screen, transition the bricks onto the screen to configure their color and add stickers, and then transition the bricks back out of the screen again to build one of these 4 figures that you see on the right. For this study we had 24 participants. The study started with an informed consent form and a demographics questionnaire. We then had participants perform this Lego building task that I just showed, during which we measured the task completion time, so the time from grabbing the first brick to placing the last brick. After each task, participants filled in the NASA TLX workload questionnaire, and we also had measured their usability through a system usability scale. They repeated this 4 times in counterbalanced order, building each of the 4 builds with each of the 4 techniques. And at the end, participants ranked the techniques, and we also interviewed them. We found that the mouse-based technique, in terms of task completion time, was the fastest to complete the task with. Participants performed significantly slower with the hand-based technique and with the modality switch technique. We also found similar results for workload, where the mouse-based technique resulted in a lower workload as compared to the hand-based and modality switch technique. The modality switch technique specifically resulted in a worse workload due to its mental demand, while the hand-based technique had a significantly higher physical demand. In terms of usability, we see a similar trend, however with this time the modality choice being significantly more usable than the hand-based technique. And then finally, in terms of preference, we found that modality choice was also the most preferred technique. So despite mouse-based being lower in workload and it's faster as well, the modality choice was still preferred to choose. And this wasn't because participants always chose to use the mouse, but participants had a very strong preference for using the mouse for the first part of the interaction, for moving the object from 3D to 2D space. However, they indicated that they used their hand from the 2D to 3D space, and this is also what we logged in our data, that this was indeed the case, that there was this divide in which technique was used for which part of the interaction. Modality switch was not preferred because it was less intuitive, which is in line with our higher mental demand that we found. And the hand-based technique, in addition to resulting in a higher physical demand, also caused participants to be confused when the object jumped into the screen as they were placing it into the screen. From all these results we derived 2 guidelines. The first is to ensure that objects are within reach of the target interaction modality after a transition. And this is due to a physical demand. So we found that participants, when they could choose, always opted for the option with the lowest physical demand. So taking the object out of the palette with the mouse-based technique to transition it onto the screen, because reaching it with their hand, they had to reach quite far to reach this palette of objects. And then similarly, when they would have transitioned the object out of the screen with the mouse, it would have been in the same plane, which is also still quite far away for grabbing it with their hand, so they preferred to just use their hands directly to take it out of the screen, because that resulted in a lower physical effort. And then we have minimized force modality switches, because for the modality switch technique we found very high mental demand, because we forced participants to perform a selection, then switch between modalities, and then perform another selection to transition the object. In terms of limitations and future work, we want to investigate more different input modalities. We now only considered hand and mouse based inputs, whereas other more specialized devices like 3D mice, for example, or even devices specialized for this type of object transition could be beneficial in this area, as well as exploring different contexts, because our Lego building task did include various aspects of both 2D and 3D interaction. However, other contexts may require different interactions and different nuances to our transition techniques, such as information visualization or computer-aided design. And this is the end of the presentation. Thank you for your attention.